Hey everyone, so I'm gonna quickly go over the quiz coming up for the end of this week. It's on station models, climate and climate change. I shut down all my other devices. I'm just going to use kind of what I have on hand, but hopefully this will be helpful for you to prepare for the quiz. So I have the quiz in front of me, so I'm just gonna quickly go through it on the side here and kind of cover what you need to know. There's the first several questions around station models. And station models are the things that let's see if I can do this right, with the circles, and that's over like a specific location. So there's a little bit of a sun issue here. So I'll just shut this. Okay, so this would be a station model. So one of the first questions would ask which location would have the highest chance of precipitation. And what you're looking for is for the temperatures to be close together. The closer the temperatures are together, the higher your humidity would be, which means a greater chance of precipitation. So I think this is showing up backwards, but the temperature is 31 and the dew point is 30. Those two numbers are close. So that means my humidity would be bigger, which means I'd have a greater chance of precipitation. So when this is the case, temperature and dew point are close. Typically this is going to be filled in or mostly filled in, because remember this is cloud cover. And clouds and precip go together. Then there'll be a question that will talk about where the temperature will go and where the pressure will go. So the temperature goes in the upper left. This is all in the reference table on page, let me just double check, page 13. I'm gonna see if I can kind of throw this up in there. That's page 13, right? Above my eyes. This is all the station model stuff. It tells you where everything goes. That's not something you have to memorize. So the second piece is they're going to give you a pressure. So let me just make one up. So let's say it's 1015.3 millibars. Right now, when it's in millibars, I can't just put it on here like that. I'm going to do the last three numbers, drop the decimal, drop the units. So if it's 1015.3, that would turn out to be 153. Apologies again if that's backwards. Okay, so you just take the last three numbers if they're giving it to you in millibars, and you have to put it into what I call station code. If this is the code. This is like the observation that you get off the barometer. The next question we'll talk about like wind. And there'll be questions to ask about wind speed, wind direction, and what determines that. So let's say that it's sticking off this way. All right, so up is north. So this would be west, this would be east. This would be then southeast wind. And let's say there's two long flags on it. Each flag is worth 10. I was just thinking in my head, I wanted to add a 5 in there just so that you could review that as well. So these two long ones, each worth 10, and this is a 5. So then I'm gonna do 10 plus 10 plus 5. That gives me a total wind speed of 25 knots, close to miles per hour out of the southeast. The next question is another pressure question, but this time it's going to be the opposite way, where they're going to give you the numbers. Let's say it's, let me see if I can come up with something more creative than 153, since I've already done that. Let's say it's 217. You look at the first number. This is going off station code and going to millibars. So you look at the first number, it's 5 or less, so you stick a 10 in front, decimal between the last two places. Or if it's 839, you look at the first number, 6 or more, you put a 9 in front, decimal between the last two, add the millibars. Okay, so that's how you do a bunch of the station model stuff. That's basically questions 1 through 5 or 6. Question 7 is going to ask about the visibility. The visibility is located in the middle. So if I were to bring this back out again, if you're looking for visibility, you're looking for the biggest number that's in this spot. So like I'll put an 8 there, but that might not be the biggest number. You're gonna look at all the station models that they give you for choices and look for the biggest number in the middle. That's how far you can see that's visibility. There'll be a question that'll ask which station is getting precipitation. They will have symbols inside of this zone. Precipitation would be sleet, snow, hail, rain. That would be your precip types. If they have fog or haze, not precip, That's just a form of condensation, but it's not coming from the sky. So it's not considered precipitation. Haze and fog just condense out at ground level. But if they had, for example, like a dot here for rain, that would be it. Or like freezing rain is like, it has like a squiggly over the dot. That would be forms of precipitation. So just remember, because this is something that students tend to forget when they're using this data chart, is we go on this page like here, there's a present weather symbol right here, and that matches down here. So this is your present weather symbols. So if you're seeing those symbols, that's where you would look. Okay, so that gets us through question number 8 of 30. And then that's it basically for the station model stuff. So first 8 questions are on station models. I use the Regents test bank to create the quiz. And so it's kind of in chunks because it divides it into topics. So this is going to be divided that way as well. So next bit is on climate. Just remember the key ideas. The farther you are from the equator, the colder the temperatures will be. So if you have like a location down towards Florida and another location in New York, it's colder in New York because we're farther from the equator. Other factors to consider would be like elevation. So if you're higher up, if you're like on top of a mountain, for example, that would make your temperatures lower, right? Higher elevation equals lower temperatures, higher latitude equals lower temperatures. Let's see, recall from the lab that we did with the 4 graph lines, one for each city, that you're going to have like less extremes if you're near a large body of water, like a Great Lake, for example, or the ocean. If you're near a large body of water, you'll have a warmer winter and a cooler summer. And you can tell if a location's in the northern or southern hemisphere based on the warm months. Now, the warm months are always in the summer, but the summer is going to change depending on which hemisphere you're in. It's the northern hemisphere if the hot months are in like June, July, August. It's the southern hemisphere if your warm months are like December, January, February. Okay, so there was a question on like the discussion question part of the climate lab, and I put that on the quiz. The next question talks about the prevailing wind map that we talked about in class. That's going to be on page 14. That's this one. And it asks why we don't really get a lot of snowfall at the poles. Poles are at the top. And the reason why is because the air is sinking. And you'll notice everywhere on this diagram that when the arrows are pointing down in the middle, the air is sinking, it's going to be dry. Where the air is rising, it's going to be wet. So you don't get a lot of snowfall at the poles because the air sinks, and that doesn't support precipitation. Let's see, talked about that already. All right, moving along. Number 14 is going to talk about the mountain effect in prevailing winds. So remember with the mountains, let's see, I kind of ran out of space and I didn't grab an eraser. So, I mean, I guess I could, it's like not that far, but let me see what I can do here. So if I have a mountain like that, all right, and I have winds coming from this direction, those are my prevailing winds. They come from that direction more than any other. Okay, let's say I have locations A, B, C, and D. Okay, so A is going to be cool and wet. B will be cooler and wetter because it's higher up. The air is getting forced up, so this is going to form some clouds, right? So you're going to get more precip out of that. When it comes down on the other side, you'll still have some moisture at C, but it's going to be drier. It'll start to get a little warmer too, because as air sinks, it compresses and warms. But D is going to be much warmer and much drier. It's at a lower elevation, plus like the atmosphere has been wrung out, plus since the air is warming and expanding, it's going to cause it to dry out even more. Okay, there's a few questions talking about like the ocean effect, ocean currents. Ocean currents were on page 4 of the reference table. So you'll have a test copy of the reference table to use. You won't be using your own. So it'll give you the name of an ocean current and you just need to find it. So let's say for the sake of example, the East Australian current here. So East Australia current is a black solid arrow. Black solid arrows are warm currents. If it was like, say, the West Australian current on the other side, that's an open arrow. And down here it says it's a cool current. If it's a warm current, it's going to be warmer on the coastline, not necessarily inland as much, but it'll definitely affect the temperature of the coastline. If it's a cold ocean current, it'll make it a little bit cooler on the coastline. All right, the next question talks about lake effect snow, and our lake effect snow areas are areas that are on the lakes. And what I mean by that is the Great Lakes. So there's Lake Erie down here, Lake Ontario up there. And so when they ask you like which location would be most affected by lake effect snow, you'd be looking for locations that are like along the lakes, like Watertown, Oswego, Rochester, Niagara Falls, Buffalo, like in those regions. So along your lines, a lot of times the lake effect snow will go a little bit inland, but it wouldn't be like as far as Jamestown. Plus Jamestown's kind of in the wrong direction. The winds usually go from like northwest to southeast or west to east. So Jamestown is a little bit south of that kind of trend. There's a question that we did in the review book that's on here about why the land will stay like ice and snow covered, even though the lake will be melted, or, you know, like open water, I mean by melted. Remember that the lake water has a delay in heating and cooling because of its high specific heat. So it'll take longer to freeze in the wintertime than the ground does, but it'll warm up a lot faster. The land will warm up a lot faster in the springtime. So let me rephrase that, because I think I probably said it in a confusing way. So because water has a higher specific heat, it's going to take long to freeze in the wintertime, but it's going to take longer to thaw in the springtime. So it's kind of delayed on both sides. All right, another question about ocean currents. Okay, some like repeat and concepts. With the mountain idea, again, that cloud cover is going to be mostly like location B is going to have the most cloud cover because it has like enough lift. Has enough lift to like force the air up. When the air rises, expands, cools, gets to the dew point, that's how you get the clouds. So that would be for location Z. And your least amount of precip and cloud cover then would be at location D on the opposite side of that mountain. Okay, so some of this stuff is kind of like repeating. Few questions more on this diagram. So again, where it's dry, the air is sinking. Where it's wet, like near the equator, the arrows converge, meaning they're like, so if I point this in a little bit more, sorry, they're converging at the equator and then rising. So they converge and rise, and that's going to lead to more precipitation in this zone, and anywhere else you see the wet zones, the same thing would be happening. Your dry zones, on the other hand, are going to be the opposite ones. It's going to be where the air is sinking and they diverge. Diverge means to split. So the air comes down and sinks and splits off to the sides. Prevailing winds. There's a chart inside the quiz that works, but you can use the reference table too. It'll give you a latitude, let's say like 12 degrees south, which isn't what's on the quiz, but let's say it's 12 degrees south. So in my chart, I just go in between 0 and 30 south, because that's where 12 degrees south would be. That means my winds would be southeasterlies. Whatever wind direction is labeled on here is the direction of your winds. That's the direction it comes more than any other. Best things to do for like severe weather. If it's a blizzard, you're not gonna like evacuate, or you know, you don't have to hunker down in your basement or anything. And you don't need to like stay away from metal unless there's like some crazy thunder snow or something. But even then, the best thing you can do in blizzards is just avoid travel, which is one of the reasons why we have like emergencies like snow days and stuff like that. The reason we have those is to stay safe and stay off the roads. All right, next bit is on climate change. 2 major greenhouse gases that absorb that long wave outgoing infrared radiation that makes everything warm up. The 2 main ones are methane and carbon dioxide. Methane comes from decomposing organic matter, like cow burps, for example. And carbon dioxide comes from the burning of fossil fuels. There's a question that talks about the influence of ash on the climate. Volcanic eruptions actually cause the climate to cool. Volcanoes are warm, yes, but they release a lot of gas and ash and things that will cause the atmospheric transparency or cleanness of the air to go down. So it'll actually cause the temperatures to drop. So volcanic eruptions will cause global temperatures to decrease. over time. But overall are still, even with major volcanic eruptions like Krakatoa and Pinatubo, our air temperature is trending up despite the volcanic eruptions. And so again, the reason why the atmosphere gets cooler with those eruptions is because the air is less transparent, meaning less see-through. Okay, so that covers the 30 questions. Hopefully that's helpful. Use your reference table, that'll help a bit with a lot of the stuff. And then hopefully this covers the other pieces of information. The notes that were used were synoptic weather maps that covered the station models. We did the chart with like practicing like conversions that might be helpful to look at again. That was this thing. So you can take a gander at that if you need a review on that piece. We did the climate notes in class. Those are posted on Teams if you're absent. And then lastly, we've been talking about climate change in class the last couple of days. All right, thank you so much. And I will see you in class again soon.